So now I'm going to discuss the case which is time to flight today. So let's go. What is time to flight and what is ground to ground projection? So let's go. Let me consider an example for explaining you guys about this. For example, this is a surface, and here the ball is present at the initial velocity, and this is ball v velocity and v dash, right? So here the velocity of a body is 0, and now the body is projected. Time. What is time to flight? Time to flight is basically time taken by a body to move from the point of initial velocity, the point of projection, to the point of impact. This is initial velocity, this is final, and both are 0 here. So the time taken by a body to move from one point of projection to the point of impact is known as time to flight, right? Here this is Vx velocity, Ux, I'm sorry, Ux, so we can see, we mostly were considering the initial velocity here. This is Uy, okay? This is the initial velocity, U. And which velocity is responsible for keeping the body in the air? Of course, the Uy velocity is responsible for keeping the body in air. So now we will consider a factor here, which is Uy velocity. So let's move. Yeah. Okay, wait. Okay. So now I'm gonna use for finding out the. We have to find the time to flight, which is, we know that the Ux is equals to U cos theta. This is a basic data that I'm concluding here. Ux is equal to U cos theta. Let me use this text for writing it. And initial velocity is equals to 0. Acceleration is equals to minus g. Okay, and I think the basic is needed is only this initial velocity and final velocity. As I told you that here the initial velocity, this is a projection. This is a projection. Here the initial velocity and final velocity, which means the displacement is 0. Okay, so this is the basic data that we need to include in our equation. So now I'm writing an equation here, which is S is equals to VIT plus 1 upon 2 A T square. Okay, let's write this data here, which is Sx is equals to U cos theta t, U cos theta t minus 1 upon 2 gt square. And after solving all these equation and all that, the basic equation that we're gonna that we will have S t is equals to 2u sine theta upon g. This is the basic not equation. I'm sorry, might have mistaken. So this is a basic formula that we will have, right? So 2u sine theta upon g. This is the time of flight taken by a body to move from this point to this point, which means the point of projection to the point of impact. This is the time, and remember that this is a complete time. Okay, let me write it again. This is done. This formula is done. Let me erase it. Delete. Let's include this one. So remember that this is the path, projectile path T. This is Q. This is R. So the distance from T to Q is represented by a small t, and then the distance from Q to R is represented by a small t. But the distance from T to R is represented by a capital T. The capital T can be equals to 2t. The small t represents the half path, but the capital T represents the full path. So this is a basic thing that we need to keep in mind while solving an equation or solving solving a MCQ that is related to, so solving the MCQ while dealing with this projectile, right? So now